Awesome. Well, welcome everyone. My name is Zach Semke. I'm director of Passive House Accelerator, and we are so excited to have you here for our first Construction Tech Tuesday. Woohoo! So I want to just say a couple words about who we are at the Accelerator. We're a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. So we publish articles and interviews, produce weekly virtual confabs like this one with passive house pioneers from around the world. And we elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews and articles and social media campaigns and videos and podcasts. So our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. And our Construction Tech Tuesdays, we do with our co-hosts, Sean St. Amour, Kevin Brennan, and Mark Wiley. And we've launched this new series to share the technique, and the technology of passive house construction tech. So each week we'll welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. And we welcome folks from all corners of the construction and design world to join us each week for this. So I mentioned in passing that our wonderful co-hosts, but I wanted to highlight them a bit more. We've got Kevin Brennan of Brennan & Brennan Insulation and Airtightness. We have Sean St. Amour of 475 High Performance Building Supply, and we have Mark Wiley of T-Stud. And these are three passive house practitioner, educator, communicators extraordinaire, and it's great to have them here as co-hosts of Construction Tech Tuesday. And with that, Sean, please take it away.
Thanks, everybody. Super excited to be here. Again, I love the passive house construction details, so love to dive into these and again, teach you not only the successes and failures that I've had, but also the co-hosts we have here today. And so for you, that if anyone's out there that's new to passive house, just want to make sure we're kind of getting off on the right start, ensuring that you understand the 5 passive house principles. We're going to talk about these a lot over the next few weeks, and especially diving today. So just so we're all crystal clear, and again, if you've no passive house, say them with me. We've got continuous air tightness, lots of insulation, 24 hours of fresh air ventilation. Make sure our homes are clean and great. High performance windows and doors, and minimizing our thermal bridges. So make sure you remember those 5. We will come back to those. You cannot build a proper house or high performance without them. If you do, it just doesn't work. You need to have all 5. So take that with it. Again, exciting to share things I've learned. And because we want to keep things rolling over, I'm going to turn it over to Mark.
My name is Mark Wiley. I'm blessed to be here tonight with these other co-hosts. A lot of familiar faces in the crowd. I've been a builder my whole life. I grew up in the lumber business as well. And I spent a lot of time educating and supplying materials to projects of other trades. So really thrilled to be here tonight. I love the audience. I love the ability for people to share and to bring forth, as Zach said it so eloquently, the technical, the technique, and the technology.
I just want to thank everyone for being here. The main purpose of this is to share with the community. I want to thank Michael for creating the accelerator and giving us this voice. In New York City, we have been doing contractor collaboratives on his site and sharing information and going over details. And it's really sped up the process of learning on site. And he's got a group of general contractors that hire specialty subcontractors like myself to do the work. And it's gotten easier and easier each project has gone on. And during the COVID and having a global community together, what better audience to share that information and those details. So just a little bit about myself. My name is Kevin Brennan. I own and operate a small insulation and air sealing company that specializes in passive house. I've also taught the Passive House tradesperson course for the past 7 years with a partnership between the Passive House Academy and my old employer, the Association for Energy Affordability. I kind of pride myself on hands-on workshops and teaching the course, and I'm inspired to work in passive house because I have a long history of working in weatherization and home performance, but I've always wondered what's the best project you can work on as a young snot-nosed little 21-year-old HERS raider out there, I was always asking people what their best blow a door number was. And in weatherization, we could only get it to 1500 CFM. But then when I heard Passive House, that you're going down to 0.6 air changes per hour and getting CFM readings on a blow a door of 300-400, it blew my mind. It's like, how do you do that? I got to get into this. So I was lucky enough to come across paths with Tomas O'Leary and put together a training program and a training center. And for the past 7 years, I've been meeting nice people that have shared the excitement of Passive House, like Michael and the general contractors and the team at Monadnock Construction that built the 27-story building on Roosevelt Island. And it's just been spiraling from there. As far as the program for tonight and the goal of Tech Tuesday, it's to get into the technical knowledge of doing Passive House. So the goal of this show is to show off that very fancy PR60 Lamelux skylight that everyone loves. But the question is, how do you get it to be airtight? How do you get it to be thermal bridge free? And what's the process? So we have a PR60, which you saw in Sean's little, in Zach's introduction. It's a big, beautiful skylight. It's 18 by 8. It's being installed by the general construction team. But this is the detail that you get from the architect. The architect draws it, they put it in, and you can see it's creating space, everything in there. But nothing's really labeled all that well. We have our architectural symbols, which show insulation, studs, framing, mineral wool, and then the triple panes glass. But how do we actually make it airtight, right? This is the shop drawing that you get from the distributor, which happens to be 475, and they actually get that from the vendor, which is Lamelux, okay? So we have a thermally bridge-free detail section here, but is it really airtight? And is everything labeled? That's a little confusing. So the next slide, they'll show even more confusion. I can almost look at this sectional detail and hear the German accent of the person who drew this and tried to transfer from metric to IP. And I'll go through this detail by highlighting some areas of questions that I had when I first looked at it. The first question we'll talk about is airtight, all right? So with the airtight, how do we make that airtight connection? We're gonna make that vapor airtight connection with Terrafoil vapor tight connection. I've never heard of Terrafoil. It must be a European thing, but they're saying that that is the airtight vapor connection, and that's labeled right here, okay? That's it, all right. So just to point out, we have this connection here, and what are we doing here? Is that gonna be Intello? So the general contractor has to figure this out and coordinate it, and then how do we make it airtight from here to here? And this is the airtightness system of the window. So there's a big gap here of where the airtightness is. It says that it's a 3mm aluminum sheet. Aluminum sheets are only airtight when you actually put some sealant on them, or are you taping? So we'll tell a story at the end with a video that we show, and we'll give a little bit of behind the scenes of that actual install. But right now we have only one airtight system here. The window, the skylight itself is airtight, and we've got some questions there. The next thing that we should talk about as far as technical details is thermal bridge free. All right. So when we have thermal bridge free, we have the roof insulation that's right here. That's polyiso, I believe, if you can't see it here. Then we have 1.5 inches of polyiso right here, and that's labeled by this right here. Then we have the extruded polystyrene, and that's labeled here. And we have the connection of the 3 panes of glass. The 3 panes of glass are thermal bridge free, as are a part of the insulation system. And then we have the window system itself, which is all thermally broken right here. So we have a nice continuous line of thermal performance here. That's much better than any standard skylight you may get. Inside the video that you'll see all the hard work that the guys from that the Passive House consultant put in of analyzing this detail and getting it from the manufacturer to what was actually built. John Mitchell's on the call from Building Type, and he does a lot of on-site work and behind the curtain details for Max Ingui to get their details analyzed. So that's my quick presentation there of airtight insulated. We'll jump into the video, I guess, from here.
Hi, I'm Michael Ingui from Ingui Architects. Hi, I'm Maggie Hummel. I am the project manager from Ingui Architects on this project.
I'm John Mitchell from Building Type. We're Passive House consultants based here in Brooklyn.
Hi, I'm Ben Lear. I'm with Vital Sustainability.
Hi, I'm Kevin Brennan. Brennan Insulation and Airtightness.
Hi, I'm Andrew Fishman with SMR Craftworks.
So I'm going to talk a little bit about why we're installing this skylight. As Michael mentioned earlier, this is in a landmark district, and this section is showing our proposed roof lines when we went to landmarks with some proposals to increase this roof line or add a large dormer at the back that would make this rear room a more usable space. They wanted to keep the existing cornice in the back so that we matched all of our neighbors. So it was important to them that we did not increase the height of this rear facade. So as a means of making this living room a more usable space in terms of head height, I'll show you a picture from before. This was looking towards the back before, where we had a pitched roof down and support beams that encroached even more on the head height. So in order to raise that ceiling as much as we possibly could, we decided to use the Lamilux PR60 custom skylight that is more than 18 feet wide. It runs almost the full length of that room, and it raises the ceiling height significantly so that it can be a more usable space without changing the roof line in the back. So this is the new section that's showing the large skylight here. We also have 2 additional skylights over the stair hallway, and we are also adding dormers in the front. But for now, we're going to look a little more into this large custom skylight in the back.
Going back to that existing photo, you can see the existing roof framing. Now, these are beautiful houses, but everybody who purchased these understands the fact that they've got to be reframed. The original builder undersized the joists and spaced them out too far. Now, over 100 years later, these have massive sags in them. So this whole house has been restructured, including the roof.
We do the supervision and installation for all the Lamilux products that are sold by 475. So this is the PR60, which is a Passive House certified unit. And I can walk through kind of the installation and the technical details to get it up to Passive House levels. So as Kevin was mentioning before, this is a kit of parts. So here you're seeing the initial framing. So these came as separate extrusions, aluminum profiles that get put together on this upstand here. And as Andrew mentioned before, the roof, is totally closed, so it's weatherproofed. It's also a lot easier to work on, so we can access all the portions. So a lot of benefits by adding this sequencing. So you see the white profiles there. On top of that is really where is a very important component, which is going to be this rubber gasket that gets actually fed into that channel everywhere. Now that gasket acts as a thermal break. It's going to break that aluminum interior with the glass that's going to sit above it. So you have a little bit of a thermal break. It's also the drainage plane. And it's also going to be your airtight layer, right? As we said, it's dry fit. So everything's compression fit. And that gasket's going to give you your airtightness. I think some important things to mention on the outside here, where you're looking at 2 units here. The one closest to us is another Lamilux product. That's a unit skylight that's a little bit simpler. It comes in that form. And that just gets placed on it has this fiberglass insulated upstand, and that just gets placed on the opening and secured in place. Behind it, you see the PR60, and you can see that the curb has been built out, the glass has been placed, there's aluminum flashing around, and there's all insulation under that flashing and in between that curb, right? So that's really where the challenging parts for making things passive is making sure that you have the continuous insulation and then the continuous air tightness, which if you looked at the picture before is coming from that Intello interior barrier and wrapped up into the unit itself. So there it is sitting on the upstand, and we're gonna come back with that Intello and make sure we're wrapping into that upstand of the curb. And then that airtight layer is running from the upstand of the curb on the profile up to that rubber gasket, which it will show later on. You can't really see it from here, but it's above the profile. You see those black portions. That's the gasket, and that's the air tightness connection from the glass compressing right onto that gasket. And that air tightness line is going to follow all the way down onto the upstand, and then the Intello is going to tie right into that.
And I'll show you a little bit about the sort of the thermal bridge analysis that we do on projects like this to make sure that the products that we're using are going to actually meet the certification criteria for Passive House, and that the installation details are going to provide really durable, thermal bridge free and details with really high surface temperatures. That's what we're concerned about primarily in a climate like this one, that we don't put a really high performance product onto the building in a way that sort of compromises the integrity of it, and that we could have condensation or issues like that. We do we did a set of thermal bridge analyses for both the sort of head detail, the upper detail, and the side detail. They're a little bit different, as you saw when Ben was describing the system. There's a system of rails, sort of U-shaped supports running vertically across the roof, and then on the sides, the condition is different. So we looked at both of those conditions and analyze those for both for heat loss, but also for surface temperature. And the reason we have to do this, Kevin mentioned that this is a certified Passive House component. So we do get a lot of information from the Passive House certificate that's provided with the component. But as you can see here, the installation detail that they're describing, they give the psi values, the heat loss calculations that are associated with these, they're really different than what we see on this project in the field. So this analysis that they have provided with their certification documentation doesn't really apply to this condition. So we need to actually look at our actual details and very closely and just make sure that they're going to perform the way that we want them to. And so we worked back and forth with Max Ingui and made some slight modifications in the way that the curb was built in order to really boost the performance and make sure that we had high surface temperatures on the interior of this window when it's installed in our roof using our system.
All right, so we'll talk about some of the details. I like to have like a pyramid or a hierarchy of Passive House process. First is air tightness, then is thermal bridge free, and the next one is functional, right, or finish. So within that process, they have the air barrier coming up the wall onto the sloped knee wall roof, comes all the way across. The Intello is continuous, goes underneath the framing, continues up, bypasses over some of the more framing, and then connects to the aluminum extrusion right here. All that aluminum metal to metal is airtight. There's some sealant between the aluminum milled finish. There's a little bit of sealant between the gaskets right here. It's a very nice install. There's no defects, no problems. A little bit of tricky tape areas are in the corner. Right here in the corner, getting it to stick. And functionally checking the air tightness with the smoke stick makes a big difference. The assembly itself is a dry glaze system in that the compression gaskets are in the corner and the triple pane glass gets sealed by two pieces of EPDM rubber being squished together. Right, so as far as the thermal performance of the skylight system that we have, I've got a thermal imaging camera here. The thermal imaging camera will show any thermal bridges as extra cold zones from inside to outside, like the corner right there is cold because that's just naturally how the skylight is weak in those corners. But as you go beyond the assembly, you see that there are no cold spots within that. If this was a traditional skylight system, the aluminum and the metal would be, quite a lot colder than 69 degrees right there. So we use the thermal imaging camera to just find any hot zones. You can see that spot right there is 74 degrees, and that's because the sun is shining brightly on there and heating that zone up. But we use the thermal imaging camera just to make sure that it's sitting in a thermal bridge-free assembly. So just another performance tool like the blower door to check and confirm. I also use this when I blow cellulose and to make sure that it didn't miss any voids or areas. It's just like that final compliance tool. So Passive House is about the process of installing, but also testing and inspecting with the smart tools. And this is one of the technology pieces that we want to add into the Construction Tech Tuesday. So a simple, rather affordable these days, thermal imaging camera could help you find mistakes. Another cool part of this thermal imaging camera is it can help you find wet spots and water leaks with roofs and other areas that might come in.
When I took Kevin's wonderful course that Kevin teaches, and provided us with great guidance and a roadmap for everything we needed to do. The next step was just going out and doing it and finding the right project for us. Fortunately, we found two at the same time, and they're completely different. One's a full, complete gut. The other one, we're leaving a lot of original joists and moldings and working around that. But through what we've learned through Kevin, we realize it's real common sense and a lot of carpentry. It really, as you know, with a passive house, you just got to draw a line over the whole thing. And if you could draw a line over your entire home, that line is your air tightness barrier. And this week on this house at 37 Sydney, we started testing our air tightness, and we put a blower door in. Our first go at it, we blew about 1.3 or something around there. It wasn't too pretty. Everyone was completely disappointed, and we couldn't believe, we thought we had the place buttoned up. But the reality is, until you put the blower door in, you just don't know. So we started walking around, trying to find different spots. Where's the problems? We found a chimney flue that was completely open, which was an easy way to knock down the number quickly. But still, there was a lot more other problems. And we spent a good...
We're on the roof here from a safe location, of course.
Yep.
We're looking at the Lamilux fixed skylights,
Right here.
which are right here. And then we have the operable, which was our access and egress up here for maintenance and to clean stuff and make sure it's done right. Then we have the PR60, which is, how big is that? That's like
18
18
by
feet wide.
about, I want to say 7 or 8.
Mm-hmm. And it's fully flash capped. Roofing systems, what, EPDM?
EPDM, yeah.
EPDM, all flashed properly, shedded away.
Yep.
And those are the details. So thermally broken, super insulated, watertight, airtight installations, roofing and insulation system up here.
So thank you for attending the Construction Tech Tuesday. Hopefully we dove into the details of the Passive House, of making airtight, super insulated, thermal bridge-free construction. Any of the details you want to talk about, please feel free to ask some questions in the chat. That's what we will be lively talking about, hopefully. It's the process of installing these technical assemblies to make sure that they're going to achieve Passive House results. So Andrew and his team did an amazing job, the teamwork and the excitement they bring to Passive House, and hopefully there'll be tons more projects just like it, and then they can start sharing. I inspire other people to get into Passive House, share the details, share the information, and become part of the community trying to achieve excellence.
Excellent. Thanks, Kevin. Great stuff. Got a couple of questions for you while we start off here. Maybe you want to just talk about the general contractor, Andrew, and a little bit about his expectations of Passive House and how he's been able to work on the technique and adopting technology.
I'm not sure if Andrew's on the call, but just spending a few days with Andrew on his site. His site is immaculately clean. When we were on site those days, they actually were running the blower door. John Mitchell was on site, set up the blower door, ran back to his office to do the Zoom call that we were doing, interrupted his workflow to create that video you just saw. But they were actually chasing down those last bit of leaks, and us being on site pointing things out actually highlighted some of the areas that needed to be, needed a little extra attention. So they did a great job, but the process of the general contractor is difficult because they have to price that out and bid it before they have really any of the true fixed details. So it's a moving target, especially on such a big item like that. And me pointing out the difference between the shop drawings and the architectural details is just to bring awareness of the importance of those overlays, and then the training of the general contractor to know where those voids might be, and take the knowledge of Passive House and fill that in with skills of how you do air tightness taping and what the materials are. Evaluating a two-dimensional plan set is rather easy with a red pen, but three-dimensionally on site gets quite tricky. So connecting to that skylight up at the top where the aluminum actual extrusion was, there were some little voids there to make that airtight. On the performance side of getting the assembly from the manufacturer, these being European style systems, they have performance data of airtightness. Some of the domestically made skylight systems that you might get may not have the same performance demands. So that's where high performance windows imported from Europe are giving you a little bit more assurance that they're going to be installed properly, especially being such a large opening, 18 by 8. If you had 0.05 CFM, that could add up really quick to quite a leaky skylight, but a domestic one, that would be great. The team of SRM Craftworks is doing an amazing job, not only on one passive house project, but two at the same time. And he's done an amazing job as far as the leadership it takes on site to lead two teams and get them down those roads and motivate them. And the thing I noticed the most on sites is that you can peek around a corner and you see somebody doing something, and you can tell who the leaders are. And there are quite a few little positional leaders. They're not title leaders. They're just people who grab the cleaning solutions and clean the window before they tape it. They know the process, and they know the way that it needs to be done because it's the right way to do it. And Andrew and his team, I think, have the precision craft of Finnish carpenters. And if anyone's ever dealt with Finnish carpenters, you can't tell them hurry up or I need that quicker. They'll throw their chisel at you and walk away and like, you do it. It's either perfect or it's not. And that's the same level of precision you need with Passive House.
No, that's great, Kevin, because again, it reiterates that we typically talk about how when we get into airtightness that, there's an air boss or an airtight supervisor that take it on. It really sounds like this entire crew has taken on that airtightness skill and adopted it and be able to, get to the levels that you're seeing here from the details.
Just one extra note on that, because Andrew is a perfect example of, because people always ask, well, what kind of contractor can I get? Do you know a passive house contractor? And Andrew is the perfect example of a contractor who never did passive house before. Kevin is a good example of someone who could be a good teacher. Kevin has taught almost all the contractors who work with us. But it's amazing to see it go from, great Finnish carpenter to learning passive house to doing two at once, very technical projects too, and really making it happen. So it kind of shows that, straight from the classroom right into it, hitting a home run. These guys are doing a really good job. So it's a good example of how really the answer of where can I get a good passive house contractor? The answer is a good contractor.
Yeah, they're able to adapt the skills. Yeah, it's one thing we didn't add because I guess it just didn't start with T, was collaboration, but we should definitely have that list of good things from the business.
That's the spirit of sharing, Michael. It's brilliant. I loved Ben's comments, by the way, on this incredible Lamilux. I mean, 18-foot is epic, but there was 4 other skylights, I believe, in my point of view, plus an accessible thermally broken skylight that was on there. And it's epic to show that, like any market, when you come across a client that's looking for high performance, a contractor can do that. And there's trainings. You don't have to have prior experience. You just have to know how to take it step by step and do your best. I love it.
Yeah, why don't we ask Ben a couple of questions, because he was heavily involved in this processes. Ben, what is the kind of maximum skylight that you can actually get that would have the glazing installed before you'd have to do what you did on this particular project? What are some of those options that come in this beautiful skylight?
Sure. Hey, everyone. It's me from the video. I'm with Vital Sustainability doing these installations for these skylight units. So thanks, John. Yeah, the largest one that you can get that's certified as a passive house component is 30 inches by 50 inches. So that's with the oversized upstand. But then some of the units which you saw in that project are not certified, but they're built to passive house specs. So you can use them in a passive house project. You just have to have someone like John or Ed do the modeling for you, to show that you're thermal bridge free. And those can get a lot bigger, up to 6 feet by 6 feet. And that's, pre-installed. So you just kind of plop the curb down and flash into it. Pretty dummy proof.
There's a couple of questions just come in, and Prudence, I know you asked one first, but I'll just because we're on the skylights here. Mary, you had a question. Why don't you hop on, Mary, and ask the question to Ben?
I was just looking at that big skylight and thinking, well, in the summer, isn't it get just so hot there? Does it need to be shaded? And if so, how is it done?
I could talk a little bit about it. It's actually a east-facing skylight. The pitch face is east, and on the large skylight, we're installing an exterior motorized shade to prevent that solar gain. We wanted to keep it on the exterior so that that heat gain never comes inside the house. And then we're also installing its own separate Mitsubishi heat pump system just for that space on the top floor, so that in some of the swing seasons, we can switch that to cooling mode if we need to. So we definitely took that into consideration.
Aggie, before you go, that photo there that you have of the before shot and the limited height space and the challenges of the existing building with the historic, what is the vertical difference of then versus now with the availability of having the skylight? The feeling the skylight gives, of course, is vast, but that true curb and extension, can you tell us that elevation change?
Sure. The curb on the skylight is 24 inches, I believe. So in our interior, we actually gained a little bit more than that. We gained about 27 inches. So it's funny to look back at the old photos because no one really remembers that space because no one used it. It was really forgotten. And now it's become the highlight of the house.
Yeah, so Maggie, like before, I mean, maybe this is, again, me not being from Brooklyn, but to me, that just seems like that's where you send the kids to go play. And if they ever come back, you'd be grateful. Is that typically what that space is used for?
We're hoping so. We're leaving it open to the staircase so that you really get a sense of that light coming in through the whole house and that it'll be a pretty frequented space in the house.
No, fantastic. Great stuff.
Did I hear that right though? 27 inches gained on the inside and 24 to the above the roof height?
We added exterior insulation to the roof as well. So the curb ends up looking a little shorter on the outside because we're running 4 inches of insulation and our roofing on top of that. But on the interior, it is a 27-inch gain.
So Passive House isn't about all about energy, right? It's about truly transformation of a space, and that height of 27 inches. That's a lot easier than digging a basement.
I can tell you, we use these Passive House skylights on all of our projects, passive or not passive. It's just so helpful. The curbs are high. It just changes everything. And in New York City, that's a pretty valuable space.
No, excellent. Okay, I know we've got about a couple questions in the queue here. Let's go to Prudence.
I was just wondering, and this is not necessarily for anyone in particular, but of all the builders that are on here that are working on Passive House projects, have you experimented with fluid applied air barrier versus tape? And if so, like, has anyone actually done a study to figure out, like, when you compare the cost of the tape versus the cost of fluid applied, and then the labor, time, and cost associated with that, like, is it a wash? Are they equal? Is one more affordable, faster than the other? Does anyone have opinions this way or experiences?
Prudence, I can try and elaborate on that a little. The answer is it depends.
Of course, that's always our Passive House answer.
It's substrate and wall type. So if we're evaluating apples to apples comparison of brownstone retrofit to brownstone retrofit, we use the fluid applied air barrier on all the party walls and the joist details because it's much easier and there's less cleaning. If we were to use a taped system or a self-adhered system, we'd have to clean and prime every one of those joists. So the fluid applied wins on that side. As far as taping a window, if comparing taping a window versus baccarat and caulking a window, in my opinion, the taping wins, just based on the clean, the prep work, and the time and the ability to check the visually that it's done perfectly. Because those caulk joints need to be done perfectly in an hourglass shape, and every 1,000 feet needs to pull test, and that nobody ever does. And you know, sometimes it's back rod, sometimes there's not, and they use the back rod that they have on site, not the one that actually is perfectly fit inside there. So there is quite a difference of those aspects. On Mike's projects that we're going for certification, we're actually bringing the fluid applied air barrier into the rough opening on the masonry. Then we're installing the window, and then the fabric or the plywood is then being installed on the window. So you're getting almost like a belt and suspenders approach of fluid applieds and the membrane-based systems like Intello and the tapes. So they're kind of complex, and maybe we'll show on a future show the window install detail, because it's evolved over the process, you know, from 88th Street all the way to 20 Garden Place to other projects, and it's gotten better and better and better. And the addition of the Viscons and the passive purples and the other airtight, you know, the other white systems and the Partels have enabled us to move quicker and faster, and it's been simpler and easier. So it's been a good experience.
I would second that. When you put in a window, to be able to tape it after you install that window and beforehand when you're using a zip type system, carpenters relate to that really quickly. They know how to roll it on. They know how to get this bond. But I love Kevin's tip of the hat of saying maybe down the road we show some tools and measuring and how you can determine if a liquid is actually done correctly.
There's a lot of variables in a fluid applied system, you know, measuring the thickness with the thickness gauge, the substrate, evaluating the substrate, how you're applying it with a spray or a power roller or other materials. So it's not as easy as it's cracked up to be, but that's probably another show, and that's the things we want to share on in this forum is the process and all the prep work. And if you just took out the technical details from 475 Pro Klima, it would show that it needs to be clean, it needs to be dry, it needs to be dust free. And I've never walked on a construction site that was any of those. And you need somebody to do it, and you need a system of doing it. So we use wet wipes that we make from Kimberly-Clark, and we wipe everything down. It's like our own little white glove test. If the wipe is white, then it's clean. If it's getting really dirty, let's clean it again. Because if it don't stick, it's not going to be airtight.
No, that's a good point, Kevin. And just so everyone knows, let us know your favorite tool for airtightness or your favorite jig. One of our upcoming shows, we're going to show some of our favorite tools. And so if you've got one, please let us know, email us separately. So going back to questions, Harvey, you've got one for us.
I think they answered my first one, which was on the solar gains. I think Maggie talked about it by saying about the about bringing in a mechanically ventilating it with a small little heat pump. So that was question number one. Number two wasn't really a question on Passive House. It was more just on about sequencing. How did you get all that up there? Was it crane? Because this is a row house. I'm just trying to figure out how this thing was. Did it go in sections? But irrespective of the sections, the glass piece has got to be really heavy. Like this wasn't hand bombed up, was it?
It almost was. So one of the hours of video footage was actual Andrew talking about the process of receiving the glass and bringing it up the elevator shaft with the hoist, and then passing it from floor to floor and up to the attic space. And they used 9 men to get the glass up there, and then they had to pass it up on the roof and place it onto that. So it's quite a labor intensive process. That's mostly done on that side because of the tight block on the historic nature of the Brooklyn Heights neighborhood, that you can't shut the street down because your neighbor is cousins with the senator or something like that. You know, a little quick note on that block, when I first went to the Passive House, the first Passive House on Sydney Place, as I was walking in to check it out and see that, hey, this is a Passive House, John Kerry was walking out. He formerly was running for president, and there he is walking out. I'm like, I think I know that guy. And he was walking out of the site there. So there's some serious political connections on that block, but so shutting down the street wasn't an option, I don't think.
So did he help at all getting it up from the elevator shaft to the bedroom up to the ceiling, or no?
John Kerry did, and he didn't even give any Heinz ketchup.
I think that's a good one, Kevin. So it's just like building a pyramid. It takes a team. Only pyramids aren't clear like these beautiful Lamelux, right?
I don't know. I was just looking at 475's Instagram photo, and they have a pyramid shaped PR60 in Minnesota that looks like a pyramid. It went on the top of a diamond shaped roof. It looked pretty cool.
I know there's some excellent projects. In the queue, we've got Deborah Little had a question.
Hi there. Hi, everyone. I was just about the exterior shading. I know that is the preferred method. I'm curious about, the Brooklyn weather, the ice and snow, and what exactly is that exterior shading like? What is it made of? Does it roll? Does it expand? Is it fabric? Is it something else?
Hi, Deborah. We are using a solar fabric that rolls on a motor. So it's placed at the top of the skylight and it retracts down, and it has sensors on it. It has wind sensors, it has rain and snow sensors. So when it detects high winds or any type of weight on the shade, it retracts up into the closed position.
Great, thanks, Maggie. And then on the note too, we got a bunch of Johns, but John had a question about the biggest factor to consider with these skylights. I don't know if that's either for Ben or Maggie, but like when you were considering that size, what were some of the things that you were worried about?
Sure. Just in these skylights in general, especially the custom ones, again, like Kevin was mentioned, location, like where is it going? How are you going to get there? So if you're starting to push the limits on glass, you really got to start thinking logistics. How is it going to arrive to site? Is it going to be craned in place? Is there enough room to maneuver where you're putting it in? The nice thing about the customization, the PR60, is that it really can accommodate a lot of different things. So it can be operable. It can have included shading in it. The glass can be varying sizes and dimensions. It can be a curtain wall. It can be a flat roof. So it's just really comes down to the architect and the specific project and making sure that all the specifications are correct for the project. And Maggie's had a lot of experience going through shop drawings and kind of going over what's specific for each project there.
And I think on our end, our biggest concern was the heat gain. We knew that it would be something we had to deal with. So we worked closely with John Mitchell, who did a lot of modeling for us on that, and Kramer Silkworth from Bowcraft, who is our mechanical engineer, just to make sure that we could offset any of that heat gain.
I just wanted to tell like a behind the music kind of story. So with the blow a door running and us filming that video, Andrew was up there and we're going through the details of how that skylight was installed. And we're looking, and Ben's explaining how the airtight system should be sealed. And then I'm looking at the aluminum, and then I start to see rivets and screws. And I ask Andrew, I say there's sealant behind here. And he's like, yeah, it's sealed. And then when we left the next day, they went detail by detail, area by area, and checked every little component of that assembly. And they found little leaks in the corners that then helped them reduce their thermal bridge number. So I think in hindsight, maybe getting some tape behind that aluminum 3mm aluminum panel may have been a little easier than trying to use sealant at the joints. But just that team approach of air sealing and the process of a sequence blow a door, I think was very important for them. And like what I do with my guys and when we're on site, nobody makes a mistake or wants to make an error when they're doing this work, but you don't see what you don't see. So getting a second set of eyes to look at the detail and to evaluate it and, raise their head and change it, because these mistakes happen not where it's easy to work. They happen where you have to work on ladders or crawled underneath some area, or you didn't have proper lighting. So that's 90% of the time of where we find some of the defects, but they really add up quick in these projects.
I was going to say, Maggie, dealing with the technology on this, right? So there's a solution that was found here. Could you share this Lamelux? The M60, as I'm understanding it, is a custom, so it can, if I heard Ben right, it can meet various sizes based on the client needs, the modeling needs, and what the building's calling for. If you can share that in the chat so other people find this link and find ways to use the data of this on their projects. I love it for the space comfort, but I really love it for the transformation to now being a useful area of the house with a sunlit stairwell. So I think it's welcoming to our industry.
Yeah, I can definitely share that. Thanks.
To to talk about, New York construction, there's right near the 9/11 site, there's the Oculus building where it's it's the train station. They've had a catastrophic failure of their roof window system, and it's leaking, and it's going to be a multi-million-dollar expense. And I was in the office and talking to Flores, and they were talking about pitching the Lamelux system there because it has so many engineered components that it probably, if that was installed there, it would have been high performance and it probably wouldn't have failed. But Ben, I think you'll be busy for years if that goes through.
Kevin, the Daily Center in Chicago was built years ago, and Gregory Hines and Billy Crystal filmed that brilliant movie in there. And that's one of the most uncomfortable buildings that's ever been built. So Lamelux, come to Chicago, brothers.
Well, if we can just keep Ben in New York for longer than a year, then I think we'll be okay. So hopefully this will keep him there. Chris had a question: can they be shipped pre-installed and horizontal?
The short answer is yes. It depends on the project, obviously, and the size. They can be pre-welded. You still need to do the flashing and some of the curb insulation on site. But for the most part, the frames can come assembled, and you would pop the glass in most of the time. Sometimes you can ship, if it's small enough, you can ship the whole thing.
Great, thanks, Ben.
Hey Ben, the skylights we got on Garden Place, I think they were craned up and they were pretty big.
That's a great example. Yeah.
I think they were probably 10 by 12, each one of them.
Each one was 10 by 12 in 3 glass fields, and they were craned. It was another tight Brooklyn block that they closed down the street, and they were craned in place. And I think the install time reduces dramatically when you can do that.
Yeah, they're fully assembled, right?
Yeah, exactly.
Yeah.
Well, mostly assembled. Still had to do the flashing on site and all that. Yeah.
True. Yeah.
Great. And so, yeah, before we hop over to Mark to talk about the next week's show, just kind of review of some of these details here again, as we talk about the technique, we're focusing on air tightness. We're focusing on connecting the different layers because, of course, again, when we go shopping for our air tightness strategy, you don't just get it all at Home Depot. You got to be able to figure out how to do that. And so again, Kevin and Maggie work together to figure out which materials are going to get connected, how they're going to get connected. And then luckily Andrew and his team were able to take on the challenge to ensure that those connections were met. Some really cool, interesting technology. Again, one is looking at not only just 2D drawings, 3D drawings, but then afterwards being able to model it. Again, a lot of times in our new builds, we're kind of just putting up our thumb in the air and be like, oh, this is how it works together. But now, again, having the data behind us and the modeling is just fantastic. And then also having thermal imaging cameras to really just prove, and this is what's nice about the blower door test as well, is that you can't fake a blower door test. You can't just pretend it's going to be there, because it'll tell you it's your lies and your truths. So really great stuff. And just a question, Kevin, just before we go to Mark, I mean, typically we're doing blower door tests at mid-construction, before drywall. But again, in your projects, because you're doing retrofits, there's a lot more things going on. Typically, how many are you doing on this type of a project?
So in a perfect world, we do about 4 or 5 of them. So if I can convince the GC to let me, we will finish the fluid applied air barrier on the party walls, these brownstones. We will cover over the windows with the membrane that we're using, and then we'll use that as masking for every large opening, skylight, whatever it might be. And then we'll run a blower door and chase down all our leaks and see what our numbers are, because now we have no penetrations, no openings, no nothing. And that's when we can check all of the party walls, the penetrations, and make sure that the one that's going to get hidden sooner than later is the party wall penetrations. And then they'll cut the rough openings and they'll start flashing the windows and bringing the air tightness inside the window rough openings. And then we can evaluate, did the windows help, or do they make it a little leakier? Most likely to be a little leakier. And then we just got to make sure. Then we'll run another blower door after the windows have been installed. Then we'll insulate the walls, and then we'll run another blower door to make sure that we cover all the patches. And then we'll do one final one at the end of the air barrier completion that hopefully has the construction main access door in, that the large rear addition is completed, and then that'll be okay. We're ready to go for finish, meaning put up sheetrock or drywall or whatever it might be. Sometimes that coordination on these larger projects doesn't happen, and we have to mask things off. And when we're masking things off, we find that most of our air sealing errors happen in the masking, not so much in the detail work. So I'm trying to get a reliable number. One of the process I've used a little more lately on these multifamily projects that I've been doing consulting on is making little test chambers and then putting the test chamber on the wall or the assembly. And then you could, it's a test chamber that you can go inside of it with a smoke stick and then check all those details. So we can take the test chamber, put it on there, and then go inside of it with a smoke stick and find where all the leaks are. But I can also give you a leakage rate of that window wall assembly that could be on there. So that could be another episode that we can talk about.
So just a note on this house versus another. So and a lot of them they're actually kind of following Kevin's kind of tools and tricks right now on this house. On past houses, we'd be weeks looking for holes, or we just gave up, or it was as good as we could get, or we doing the blower door the way we're doing them in this house, or I didn't do it, but the way they did it, I did so much. I drank coffee and watched, but they ran the blower door on this, and then for a couple of days, they started, they had their guys at the top working their way down, kind of the way Kevin's describing. In 2 or 3 days, they're hitting the number, and they're done, and they move on. It's like it's forgotten. They hit the number, they know what they got to do, and now they can close up, they can sheetrock, they can do everything else that construction involves. So it is really following those tricks that for me in our houses, and this house has a lot of technical details, dormers and skylights and additions and weird corners, to doing that kind of stuff for 3 days versus forever. It's what makes Passive House affordable versus not affordable. So I feel like kudos to Kevin and the folks for kind of bringing us to that point.
So I just want to be clear. I did not work on this project. I am taking credit for all of Andrew and John Mitchell's hard work. I showed up with a video camera and pointed at some airtight details. I have not worked on this project whatsoever. I taught a class for 5 days and was like, good luck, buddy, go get them. I mean, all the hard work was done by Maggie and John and Andrew.
Big thanks to John. Yeah, they spent a long time looking for holes.
And it's about the process and the tools. The tools that we've developed is using the chemical smoke stick that we use, that they don't make anymore. And there's new tools coming out. We have, it's just improving the process of finding leaks a lot easier, but also making it so that the guys doing the work fix the errors, as opposed to somebody else finding it, because you don't want to make the same mistake twice. The person who caused the error should fix the error, and you should show them why it happened. And 90% of the times it happened because it wasn't clean, or it wasn't dry, or there wasn't proper lighting to see what actually you were sealing. And sometimes it's just that detail it's not able to seal. When you're sealing 100, 200-year-old joists that are cracked, there's no way to make them seal. That's why Passive House Retrofit gives you one air change per hour is the threshold, because it's not easy to hit these areas. So
no, good point. And we're going to wrap up here quickly, but John Mitchell, hopefully you can stick around in the overtime and we can ask you about some of these critical details that you got to play around with and find. So stick with us. Mark, let's go to you.
Yeah, before I continue, in the later part, John, I think it's good if you could tell people what modeling is. Some people may not even be familiar with that and how important it is. So that's always, I think, the breaker. Thank you, Kevin, Maggie, Ben, and those that weren't here, everyone at Backstage. The rest of the folks that will be joining next week are not with me now because they came in from Massachusetts and Texas and Minnesota, and the film crew is still filming. We started at 7 a.m. So I got a reprieve and I get to sit on my butt and watch the presentation tonight. Again, heads up, Dylan, you're getting a lot of stuff your way. So 18 feet skylight is a great segue to next week's 18-foot off-site produced steel, prefabricated, pre-finished, thermally broken, cantilevered deck. It is nutso. It's connected with 8 bolts. I just gave all the secrets away. Now you can all go build one on Saturday afternoon. So easy to do. So it's really epic. We had a crane there all day. It went so quick. It was like flies on stank. And I tell you what, the people joining us next week are names you're probably familiar with. There's a gentleman named Stephen Basic. There's a gentleman named Jake Bruton, and there's a gentleman named Matt Reisinger, and they're going to give us the lowdown of this project in Missouri. And today they invented not the California corner, they invented the Mo corner. We're calling it the Missouri corner. Check Instagram, Sean, for the hashtag Mo corner. In 1 hour got 7,000 views. I don't know what that's worth. With that and 50 cents, you could get a glass of water. But happy that this happened tonight. I tip my hat to Michael, to Zach, to Kevin, and Sean. We just thought of this idea on Sunday morning. So glad you could all be here tonight. And bless your hearts for inviting people each and every week to learn about technology.
Great stuff. And just before we go and we let you all go and we dive into the overtime, we also just want to recognize some of our heroes. And Kevin wanted to share a big thank you.
Peter Spafford was a trainer for the Air Barrier Association and the quality assurance director. And I had the privilege of working with Peter at the Air Barrier Conference, and he taught me to be an auditor. But he was a mentor to me on how to train and how to teach. And he passed away a few weeks ago. And he was just an immense person and very passionate in the home performance industry in Canada and the US here. But the air barrier industry wouldn't exist without the work that Peter did. And I wouldn't be the person I am or the trainer I am without Peter's mentorship and guidance. And my little recognition here is to make sure that if somebody's mentored you, to give them a phone call and tell them thank you and how much you appreciate it, because I personally would like to rewind time and let Peter know exactly how much I valued his mentorship and his kind words and get me to that next level as a trainer. So I have a platform and I'd like to share, but one of the nicest gentlemen I've ever come across. So just thanks everyone for that moment.
Great stuff, Kevin. Zach, do you want to say thanks to all the people that made this happen?
Yeah, absolutely. So all of our work at the Passive House Accelerator is made possible by support from our sponsors. So I want to thank our sponsors. Our founding sponsors are Baxton Ingui Architects, Mitsubishi Electric Train HVAC US, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are Morrison Hershfield, 475 High Performance Building Supply, and Partel. And I also want to do a quick shout out for our happy hour tomorrow. It will feature Marisa Ejea and Elena Reyes about a really cool pilot program of Passive House in Mexico. So join us tomorrow. Thank you.